Good morning, friends. In this video we are going to learn about stereographic representation of complex number. Stereographic representation is like if you think a plane, organ plane, and you are folding that plane to a sphere. So that kind of thing is going to happen here. To know the stereographic representation, you have to recall spherical representation. So what is spherical representation? Spherical representation, we only know that XYZ system, three-dimensional coordinate system. So here we are representing that XYZ in terms of r, theta, phi. So XYZ system to r, theta, phi. This is spherical representation, spherical coordinate system. So if you draw the traditional three-dimensional system, this is x-axis, this is in general notation we take in this is y, x and z axis. Now take a point in the space. Suppose this is a point P and with x, y, z as the coordinates. Now take a sphere passing through that point. Now you have to fix with this point with that sphere. Now the first thing is radius. So take that point and connect with the origin, and that is the radius. So first thing is clear now. Second thing, theta and phi. So if you take the angle with the z axis as theta and the angle with the x axis, what is that angle? Take a perpendicular from xy plane to that point, join origin to that point, and this angle, if you take this angle as phi, then the system will be represented and fixed. If you take this phi, you need not take that angle. It is pi by 2 minus phi. Now what is the relation of this xyz to r, theta, phi? To that we are drawing first. Take this triangle and we have assumed this is r. So this distance is r and we need this distance at z. This distance is equal to this distance. It is not looking like same, but you have to imagine that this point and this point, if you are connecting this point to the plane, so this is flat actually. So this distance and this distance are same. At least imagine. Now what is this value? This value is r sin phi. So take z equal to, z means this height will be equals to r cos phi, r into cos of theta, sorry. So r into cos of theta. Is it okay from this triangle? Now second thing, x. So x, you need to find that relation from x. So x is this distance and join this line, and you can join this line also. So this distance and this distance are same. So this is the x-axis. So x-axis and this is this line. What does this line mean? This line is equal to this line, this line and this line, is not it? So this line is r sin phi. If you write here r sin theta, sorry, and so this is equals to r sin theta, and in that case x equal to So r sine theta into cos phi. Similarly, y equals to r sine phi, this angle, into sine phi. So this is actually y distance. So y distance will come from the sine formula. Sine phi equal to this is this by this, and hence this value will be equals to r sine theta into sine phi. Now this is the relation of xyz with the r theta phi, but here our main purpose is to understand the stereographic projection of complex numbers. So spherical representation is now okay. We have understood this. Now let's start with stereographic projection. Okay, you can remove this. Now stereographic representation, for this we have to draw one plane and one sphere. So sphere, and this is extended complex number system plane, you can say Argand plane, and this. Now take origin. Okay, so this x-axis, this is y-axis, and this is z-axis, and this sphere is unit sphere. The radius is taken as unit. Now put a point in a complex number plane, Argand plane. Put a point here and connect that point with the north pole, like this. Now it is obvious that if you draw one line from north pole to the plane, the line will intersect one point at the sphere, and this point, if you take this point as P, and if you take xi1, xi2 and xi3 here, so we will find some relation. And this point, if you take this is as x plus iy, is there any kind of mapping from this point to this point? Is there any kind of relation from any point in the plane with a point at the surface of the sphere? So we will investigate that, and if you relate that coordinate system, that spherical system with this, then we have assumed that the coordinates are xi1, xi2 and xi3. So put it here, xyz as xi1, xi2 and xi3. So this is xi1 basically, xi2 and xi3, and we have taken the sphere as unit sphere, so radius will be 1. So if you remove that r, it will be sufficient to represent this. Now in this sphere we have xi1 equal to this, xi2 equal to this and xi3 equal to this. Now take this and two perpendiculars from that point to y and z axis. So naturally this distance is nothing but xi2, y axis, xi2 here, this is xi2, and this is xi3, Now uh, we have to find the ratio from this triangle. Check this one divided by the whole thing is y. We have assumed it x plus iy, the point in the plane. Now this distance is the y distance and this is j2. So this by whole will be equal to this by whole. So I'm writing this j2 divided by y will be equals to this distance, that is 1 minus j3 by 1. Any kind of confusion? So in that case you have to read the basic properties of triangle from class 8 or 9 textbook. But if you just imagine is it true or not, you can take any triangle and right angle triangle. Now put a point here and join these two. Now this by this will be equal to this by this. Still it is confusing. Now take this type of triangle. So I am saying this result, this distance divided by the whole will be equal to this distance by whole. Now it is looking like perfect. So this is the longer part and this is the longer part. If you take this type of figure, then this, the smaller part divided by longer will be equal to that smaller part divided by the longer. So I think it is okay. You understood this, and you can check the proofs. And similarly we can write from this side that j1 divided by x will be 1 minus j3 divided by 1. So from that we can write, so x equal to j1 by 1 minus j3, and from this we have y equals to j2 by 1 minus j3. Now, so if you put j1 from this relation sin theta cos phi divided by 1 minus j3, and that is cos theta, so this divided by 1 minus cos theta will be 2 sin square theta and 2 sin theta cos theta, so it will be equal to cos of phi into cot of theta by 2. Check it. Similarly here from y, j2 is sin theta sin phi, and divided by 1 minus j3 means cos theta, so similar way we can find sin phi into cot of theta by 2. So ultimately we get that x plus iy equal to, so sin phi cot phi common, take that, and cos of phi plus cos of phi plus I sin of phi, that is e power I phi. So this is the relation. Now take z equal to, that is the any complex number can be mapped with a point in the sphere. So this is the mapping, and you can check this mapping is bijective mapping, and so the conclusion is that we can find a point from the plane to a point in the sphere. And if you think about the north pole, and you are connecting to a long distance point, actually that is the extended complex number system, and it is going to map the infinite number, the infinity. So basically, if you draw any line through passing through that sphere, you will find the complex plane anywhere. And if you want to connect the infinity, then like this. So in that case, infinity is mapped to the North Pole only, and all other points are mapped to any point in the surface. So this is the representation, this is the stereographic representation. Hope you understand this, and if you have any kind of query, let me know in my email address. Thank you very much, and we will discuss analytic function and the related properties in the next video. Thank you. Bye.